Hi, and welcome to this Lernard.com chapter on Jenkins and CI. In this opening introduction, I'd like to introduce the concept of a build server and go through some of the reasons it's so important to the DevOps stack. It doesn't do to break with tradition, so first of all, let's take a look at this stack in a diagram here. If you aren't familiar with it, I'd recommend popping over to the homepage of this site and watching the introduction video there for a quick overview of what this means. So far, we've been looking at Terraform and Ansible, which deal with the provisioning and configuration layers of this stack. And the only time we've touched on deployment is when we've copied over a simple index.html page to the web root of our server using Ansible. HTML code doesn't require any building, and our simple copy of the file represented the simplest possible form of deployment only. But of course, in industry, websites don't just use HTML. Usually you would expect most complex enterprise sites to have both a front and a back end, written in such languages as Java, Python, C#, JavaScript and PHP, plus all kinds of other ones, just depending on the use case. These languages have a more complex set of needs during their journey from a developer's laptop to the production web server than simply copying a file as we used in our HTML example so far. Firstly, most languages used in industry will have dependencies. If you're a developer, you'll be well familiar with this concept already, but for those of you from a more infrastructure background that this concept is new to, imagine we decided that we were going to build ourselves our own home. Once we'd made some architectural diagrams of the sort of home we might like, for most of us the next step in the process wouldn't be to visit a quarry and hew ourselves blocks from the very living stone face, nor would we attempt to melt down sand and pour ourselves sheets of perfect glass of the appropriate size for our windows. That would be fairly insane. It would be far too time-consuming and expensive, and anyone in full possession of their sanity would go and buy these things from a building supplier before beginning construction. Code is exactly the same as this in the modern enterprise. Unless the website being created is quite simple, most modern development includes the use of pre-made tools and packages that can be assembled just like pre-bought building materials. In this section of example code here, we'll be making heavy use of in this chapter. You can see that I'm declaring my dependencies, and underneath I list all the building blocks that I want to use. For example, our website is going to be in React, a JavaScript library used for building user interfaces. So I'm just installing that into the site here rather than having to create all the features of React myself from scratch. This is incredibly useful and has revolutionized the quality of modern web development. But any site that has dependencies require that they be installed before the site can be deployed. So already the process is more complex than a simple copy. Most languages also require compilation before they can be used. If we consider this line of simplified Java, though it may look technical, it is actually designed to be easily readable by a human. Words like public and class are human words and not easily understood by a computer. Computers speak in machine code, composed eventually of a series of ones and zeros, and the act of compiling something is simply converting the human readable language into a language more efficiently understood by machines. So, if we look at our simple DevOps stack here now, we might feasibly expand out the build layer to look like this. No one ever does this in reality when they draw the DevOps infinity wheel or the DevOps stack, partly because it doesn't look great, but also because all these things are handled by a single thing, the build server, which in our case is going to be Jenkins. There are a huge amount of other competitors out there, by the way, such as TFS, TeamCity, CircleCI, Bamboo, and many more. But as with all my choices in this course, I've gone for Jenkins because it's one of the most popular, it will be one of the most profitable in a work environment, and also because it's free and open source. If we consider the journey of a piece of code from a developer's laptop to a customer-facing server, it might look something like this. Before any code is pushed to GitHub, Jenkins is watching the repository at regular intervals, waiting to see if there are any changes since the last time it looked. When a developer uses Git to push their change to GitHub, Jenkins will notice and it will pull that code down onto the server using a Git clone. Once it has the code, it performs a series of predefined steps that we're going to create in this chapter to automate the things we described, installing dependencies, compiling the code, perhaps packaging it up, and then finally deploying it to the server. This logical progression of code through a series of steps, starting at the developer's machine and ending on the server, is called a pipeline, because the code flows down it in one direction, just like water through a pipe, with operations being performed on it as it does so. I should say that even this is a pretty minimal pipeline here, and enterprise pipelines often contain tens of steps. Certainly at least it might consider testing and analysis and all kinds of other goodies, some of which we'll be covering in this chapter. But regardless of how many steps you have, the concept is identical, that of Jenkins automating the process of a delivery pipeline. Often, in reality, the server at the right-hand side of this diagram is actually a test server rather than production, and the final step to go to production where the customers are visiting is controlled by some kind of manual process. As companies are naturally cautious about making changes to their money-making estate, and often have business-relevant reasons why they don't want things to be automated, such as releasing a new feature to be timed with an advertising campaign. If a company has such a reliable pipeline that they allow code to make it all the way to production without any human intervention, it's called continuous integration, and is somewhat of a gold standard to aim for, though often out of reach of most businesses purely for practicality purposes as well as technical maintenance. Because of this, Jenkins and other build servers are often known as CI servers, but the terms are synonymous. Right, I think that's enough to get going now, although there's quite a bit more that we're going to cover later in the chapter. We've got enough to get started. Let's head on over to the next section where we can have a look at how to install Jenkins and then go through a couple of simple demos to show what it can do. Hopefully see you there.